All right. I've spent the last 2 weeks doing unspeakable things, Wade, but I think we're going to be finalists in the Australian Podcast Awards. It'll be all worth it.
What, going to be? Well, dude, we've been finalists now for like 4 weeks.
Then who was that guy in the car park? Oh, Jesus.
Dude, I don't think that's a judge, man.
Oh, look, this is a chapter I want to close in my life. I'm going to go to the doctor. I get a penicillin shot or something.
Well, what are we going to do this week's episode on, man?
I don't know, just ask some followers some fucking questions or something.
All right, let's get to it. Hey, buddy.
Hey, Wade, what's going on, mate?
Not much, man. We thought that we'd ask our listeners and our followers on social media if they wanted to ask any questions this episode, because we like to do that every once in a while.
Yeah, it's good. Keeps it a bit fresh.
We don't
go too deep.
Yeah, and as well, some of the questions we get will actually base whole episodes on as well. So, for those people who have asked us questions...
some of them were shithouse. We haven't answered all of them.
Some of them, yeah. Guys, some of them were terrible.
Some of them were borderline pornographic. I'm not answering some of them.
But did you get my photos? I hope, yeah. We thought that we would listen to you guys and get you guys to ask us some questions. So thank you for everyone who asked questions, though. It's always great to have that engagement on social media and via emails and things like that. But we've just picked a handful because if we would answer all the questions, the episode would go for about 2 hours. And I think by the end of 2 hours, you and we would be very bored. So let's get started. Okay, so would you like a funny one first, Bern, or a serious one?
Oh, let's go a funny one. It seems our followers were more inclined to ask us humorous leaning questions than serious scientific ones. I wonder why.
I don't know. Okay, so let's have a look. All right, what's this one? I can't even read. Mate, your handwriting is terrible.
Mate, that is perfect handwriting. Your handwriting looks like a girl's.
So if the two of you lost all your morality, what pseudoscience would you hawk to become millionaires? That's from Kent Borman.
Ooh, I reckon I'd go for crystal healing. You're just selling rocks. How good's that? That's just walking around your backyard, picking up some good-looking rocks and selling them on as some sort of healing ability.
I'd say coffee enemas.
You just like sticking things up people's asses? Or?
No, I'd just like to meet someone who would be willing to have coffee shoved up their ass and just to meet them and be like, what were you thinking?
So I haven't done this before, so I just like a macchiato.
Yeah, sure. Yeah, no one's done this before. Yeah. Yeah.
Do they have mocha?
Yeah.
Coffee enemas? Or
I don't know.
Can you get a cappuccino?
That would help.
What if you're lactose intolerant?
I wonder if there's they have get together and it's like, you know how you talk about where nice coffee is, like, oh, it's just the nicest coffee enema. It's this little place in the city that's a little bit tucked away from the main road, but they just really get it up there, you know.
Who was the guy that went to a place to get an enema and was like, there's not enough caffeine in this?
And as well, do they have different brands of coffee? Is there a certain,
There's that super expensive type of coffee that gets eaten by a jungle cat and then gets shut out. The bean passes through them, and it's really expensive, and they pull the beans back out of the feces.
What a load of shit.
No, literally, yeah.
No, I'm just saying that's an utter wank.
Yeah, it is. I'm eating shit coffee.
Yeah, oh, God. And they promote that.
Yeah, I bought some a while back for... not a person I was a big fan of, as hey, I'm back in the country, here's a present I got you.
Are you serious?
Yeah, I did. It was hilarious. Didn't tell him what it was.
But I knew in my mind, I was like,
he's eating my shit coffee.
I think I'd just like to meet someone who's willing to have coffee just injected into their asshole. They'd be like, what are you thinking?
I don't know. Maybe they were a bit ashamed when they were getting regular enemas because it was coming out so brown. They're like, how can I cover this up so I don't look so dirty on the inside? Coffee.
Coffee.
Obvious.
Until
we get Coca-Cola enemas going.
Close second would be, those ones where you send people money and they think happy thoughts for you.
Oh, yeah, that's a good one. That's even less than collecting rocks.
That's less of just you sitting on your fat ass watching TV
Would
and
you
literally
actually
getting sent money.
Happy thoughts, though?
God, no. I'd be like
thanks, idiot.
Yeah, thanks, idiot. Yeah. Exactly.
I feel like I would. I'd think happy thoughts.
It wouldn't do anything.
Yeah, so what? I didn't say it would. I just said I would think happy thoughts about them.
Happy thoughts. Wonder if you could do something where it'd be like, oh God, this is like, send me money and I'll jerk off over you. Do you reckon there is? Do you reckon there is someone out there?
If there are people out there willing to send Wade money, he will jerk off for you.
No, I'm not saying that. I'm not saying don't send me money. Send checks. Digital transfers. Okay, so Carter David. Now, this is a more serious question. He said, what's the biggest stumbling block in developing wide-use fusion energy, and how can we fix this?
Ooh, that's a good question.
It is, yes. And so thanks very much for that, Carter David. The thing is with fusion is as there's not just one thing. There's a range of things, and there's a range of reasons why it currently isn't being used, and really it's not currently an effective way of generating energy. What they've found is with a variety
more
of
energy input than you get out of it.
Yeah, well they are getting there, but it's not worth the. It's very hard for them. Let me go over a number wide. Okay. Yeah. So obviously a number of design setbacks. It's an emerging technology. So as time goes on, obviously get better designs and people trying to do different things and cause different types of reactions and processes and mechanisms that will follow through to create fusion. Funding cuts as well. Like one of the best ways that we can actually promote and get this technology advancing is through obviously funding. The US, is threatening to kind of cut back on that type of fusion reactor. There is funding from all over the world, and it's kind of cool. It's a little bit like CERN in the sense that there's a range of different countries putting money into this kind of fusion technology, which is fantastic. And it's always great when you get different nations working with each other to help solve energy problems and things like that.
Science, isn't it? Collaboration.
It is.
Even if some scientists aren't very good at it.
And mainly as well the technology. So like fusion is just like a rather simple process. Okay, you get lighter elements, you fuse them into heavier elements, and then they release energy. It's all got to do with E equals mc squared. So to kind of put it, it's rather strange as well because it's
like all of Earth's energy really comes from a fusion reactor we call the sun, right?
Yeah, well, that's how the sun shines, and that's how it releases energy. It's how it releases heat. It's what gives the Earth life.
Yeah.
And I'm sure somewhere else in the universe it's doing exactly the same thing. But the problem is, and the weird thing it is to imagine, if you have 4 Lego blocks, right, and you have them separate and you weigh them on a scale, and it comes back as, let's say, some unit of 4, and then you put them together, stick them together, it's still going to be 4, okay, on the scale. However, when you're dealing with subatomic particles, that changes a little bit. So if you get all these subatomic particles and you lay them flat out, not connected to anything,
as individuals, weigh them
individually, then they'll actually have more mass than when you put them together, which is kind of strange.
It is strange, but that's the E equals mc squared. That's the energy and the mass.
That's exactly right.
It goes.
Yeah, and so those kind of forces between these particles act, and even just the way they're arranged can actually change the amount of mass and energy that's there. So it's really not as simple as
E
equals mc
the
squared.
Lego blocks as well as
it's the bond between the Lego blocks that sticks the Lego blocks together that actually changes their mass.
That's cool.
It's really strange.
So what's our biggest hurdle? We just don't have the technology available right now.
Well, one of the big things is the temperature at which we need to actually suspend the hydrogen fuel at, which is 150 million degrees. Yeah, so as you can imagine, they've done that, but they've done it in like separate reactors, which obviously
hotter than Margot Robbie in a swimsuit.
Exactly. Isn't she fantastic? Represent.
Good old neighbours.
Yeah. That's one of the problems is that we can get them to this, this heat and get them, working and levitating at that kind of, at temperature and the collisions and things like that. But it's really hard to get them working all together as one and to maintain that huge amount of heat.
That's a huge amount of heat to generate to start it off.
Well, the only way it can naturally occur in nature is at the center of a star.
Yeah.
That's really the only place where that type of fusion can happen. And even our sun isn't hot enough to burn large amounts of the heavier elements.
Could we argue that solar panels are a form of fusion energy?
How's that?
Because we have a fusion reactor powering them. the sun.
No, that's got more. Solar panels more have to do with the photoelectric effect.
Yeah, that's true, but still.
That's just. Well,
I suppose you could argue everything's a
but
fusion energy then, because that's where the coals come from fusion energy, wind comes from fusion energy.
Yeah, that's true.
Could you argue all energy is therefore fusion, really?
No, it's all just transformation of energy from the sun.
Yeah.
So
all energy starts as a fusion reaction, really, in Earth.
Not quite, because in the early parts of the universe, when there was just hydrogen, helium, and lithium, like they would have had kinetic energy, which is enough. Like they popped into existence without the fusion of the star.
Gravitational potential would have been there as well.
Yeah, gravitational potential. Like, there was that energy.
Physics.
Yeah, the energy output of the universe hasn't changed since Big Bang. It was, except with the Big Bang, it was more just spread out and evenly distributed. So that's why one of the things that Alexander Friedman, who was a Russian mathematician, came up with when he looked at Einsteinian general relativity, said that the universe would look the same in all directions. That's what he meant.
Okay. And eventually we got the heat death, and it'll be distributed, but over a much bigger area.
Exactly, and then this same amount of energy, more space.
Okay, fair enough.
Yeah. Okay, so our next question comes from Mitch Mazzaros. And
Looks like Mazzaros.
Mazzaros? I think so.
Yep.
He said, "What's your favourite dick joke, Bern? What is your favourite dick joke?"
Well, I've got a few, but my dad's actually been collecting them. So I decided maybe...
He's got a catalogue.
He has. So maybe we should give him a call and see what his best one out of the catalogue is. What
All right. Get your phone.
I'll give him a call.
Hello?
Hey, Dad, it's me here. Look, we've got a follower who's written in and asked us a question about our favourite dick joke. Now, I know you've been keeping a couple for occasions such as this, so I thought I might give you a moment to shine. So, what's the best dick joke you've managed to collect?
Got a few. The best one, I was in bed with a blind girl last night, and she said that I had the biggest dick she'd ever laid her hands on. I said, "You're pulling my leg."
There you go, Mitch. That's from my dad's own personal catalogue. Thanks, Dad.
No worries, mate. See ya.
Wade, do you have a dick joke?
That was awesome. That was awesome. That was so good.
I'm going to go and get his list now. I think
I love how he's like, "I've got a few." It's like, you have a complete catalogue. I'm supposed to be like moves like a statue's head, and then just this, like, the bookshelf moves and just... Yeah.
It's on a statue's head, yeah.
So, yeah. Oh, awesome. That was... Okay, there you go. That's, in honest, that's my favourite dick joke.
All right. Next question comes from Ben Straney. If Sci-gasm was a superhero, what would its powers be? Whoa.
Last time I mentioned anything about superheroes, I stupidly put Wonder Woman's lasso of truth.
But how cool is Wonder Woman now the movie's come out?
Yeah, you gave me shit about that, and everyone's like, "Oh, wow, what an amazing character." It's like, yeah, fucking damn right.
Damn right. Lasso was a superpower.
I would say, you know what, I'd actually go out and say, if we were a superhero, I would say Lasso of Truth is pretty good, because we try to be as honest as we can, in our research and our biases and stuff like that. So I'd say it would be our superpower, calling out bullshit.
Yeah, okay.
Yeah, what's yours? Or what do you think?
If we had a superpower, invisibility, because we're a little bit creepy.
Yeah, true. Yeah.
Can't argue with that.
Yeah, what's that one? What's that superhero who's always getting drunk? Will Smith played him.
Oh, Hancock.
Yeah. It'd be a mix between Wonder Woman...
Or the evil Superman.
Yeah. It'd be a mix between...
He gets all cranky and starts flicking beer nuts at the bottles and stuff.
Yeah, that's what I reckon. It would be a mix between Hancock, Wonder Woman, and, I don't know, some invisible person.
I don't know. Yeah, maybe.
Yeah. I don't know.
Thor.
Mystique. We'll say Mystique. Yeah.
Thor.
Why Thor?
Because I like to hammer shit.
Okay. Let's have a look. Okay, so what's this? Malcolm... What's that? Boynton?
I think it's Malcolm Boynton. So, we should apologise to everyone whose names we attempt to pronounce in this episode. Sorry about that.
Okay, if it takes 365 days for a mouse to cross the Atlantic on a crowbar, how high does a seagull have to fly to split a shingle with a bird turd?
Oh, that's rubbish, Malcolm.
That's fucking shit.
Firstly, the turd's going to hit terminal velocity.
So it won't go any faster.
Yeah.
Then as well, you look at the intermolecular forces of the shit itself, and they find that it would start to separate because of the,
especially
obviously
if it's
the
bloody
air
high up,
resistance.
you know?
Exactly. So,
What the hell does it have to do with a mouse on a crowbar? The crowbar's going to sink to the bottom of the ocean.
yep.
Mouse is not going to float on a crowbar.
Yep. And then...
And if a mouse was out of the ocean for a whole year, it would die anyway.
Yep.
If something didn't come and steal it.
And even then, with the bird turd splitting apart because of the air resistance, then you'd find that it would start to lose momentum as well. So its momentum would, and even its impulse of where it actually hits that point, would actually be more distributed, which means you'd have a force over a larger area, which would then mean that it would reduce the chance of it splitting the, what was it?
The shingle, the tile.
The shingle.
Yeah, what a shit question, Malcolm, really.
Fuck you, Malcolm.
What was that? Oh, mate. Try harder next time. We appreciate you putting your input, but...
Poor Malcolm. Poor Malcolm. We're just kidding, Malcolm. Thank you very much for sending that question in, but it was a stupid question. All right. So what do you got for us, Bern?
All right. Catherine Lockley asks... Oh, it's a double-part question.
Oh, two-part question.
Why are teenagers obsessed with is water wet? And what is our answer to is water wet? Well, I actually had a bit of a look at this because I was like, that's an interesting question. And I have heard the recent talk of is water wet out there. First part of the question, teenagers, I would say, are curious because like all young persons, they are naturally curious. Babies are naturally curious. Young people tend to be naturally curious. Our curiosity seems to die as we get older and we think we know more. Teenagers are also argumentative, and a question like, is water wet, is an easy question to address and even easier to argue about. So I assume teenagers just love that. It's easy and easy to argue about, right up their alley.
Yeah.
The question of, actually, is water wet? I would actually argue no. Water itself is not wet. Okay?
Okay, so here's my reasoning. Like, you've looked into it more and you understand more about it than I do. The reason I would say water is not wet is because for something to be wet, it has to be immersed in water, thus having the property of being wet. But it's like saying, is slime slimed? Well, no, because it's slime. It is the thing that makes the other thing have that property.
Yeah, I know what you mean, and I think I tend to agree here. So my argument here, and there's a really good video by Kyrgyzstan, or in a nutshell, called Emergence. It's about emergence. It's
I always forget that channel's name, and I'm like, Kazakhstan.
Kazakhstan. Why do I keep seeing Borat videos? But they talk about this idea of emergence or emergent properties, and wetness is an emergent property. So think of it this way. If you've got one water molecule, it's not wet. It's just a molecule by itself. If I stick another water molecule on it, does that make the first water molecule wet, or is the second water molecule wet? Because it now has water attached to it. And I would argue neither of them are wet. So you scale that up and you get a whole bunch of water molecules stuck to each other. None of them are actually wet because they're all individual. They can't wet each other and be the source of wetness at the same time. So a glass of pure water means that the water itself is not wet. Okay, this is about an emergent property. So what you can think about with emergence, and this is the example they give in Kyrgyzstan, is like life. So you look at atoms. Atoms themselves are not alive. Atoms make up molecules, and molecules have different properties to atoms and work differently to atoms, but they are still not alive. Okay, you get a bunch of molecules, you stick them together, and you might have something like a protein. Once again, proteins do specific jobs. They can form and change shapes, but they're still not considered alive, and they are different to molecules, even though they're made of molecules. Okay. And then you go up from proteins, and proteins make up cells. Now, all of a sudden, cells are made out of the same stuff, made out of atoms, made out of molecules, made out of proteins, but for some reason, we consider cells alive. It's an emergent property. Only when it gets to that level is it then alive. Okay, and this is emergent, so you get bigger and bigger and bigger, and that's when the property kicks in. So water itself, I would argue, is not wet. The presence of water on something makes something wet. That would be my perspective anyway. I hope that helps you out there, Catherine. I would say water is not wet. Water is an emergent property that makes other things wet.
Yeah, we can't shed light on the why are so many people are obsessed with that question of a certain age group, but well, I thought, Bern, you did a good job with that one, mate.
Thanks, mate.
No worries, champ.
It's an interesting question. It's a good philosophy question. Maybe a question for English teachers or something.
Okay, so the next question comes in from Ben Merritt Troop. Can old non-stick cookware leak toxins and cause cancer?
Oh, that's a popular question. Great one.
Yeah. So in short, no, as far as we're aware. The reason is, okay, so this is from the Cancer Council. Teflon, or PTFE, or polytetrafluoroethylene, okay, and the this is really hard. Perfluorooctanoic acid, so PFOA, is actually burnt off during the making. Okay, so the actual Teflon's name is the polytetrafluoroethylene, which is the PTFE.
Okay.
That's actual name, the brand name is Teflon.
Okay. So that's the chemical, that's the brand. Gotcha.
Okay, and the one of the chemicals used in it is a perfluorooctanoic acid, the PFOA. This is the thing that most people are concerned about, but during the process, so the making process, it's actually burnt off and it's not really present in large quantities in the final product.
Okay.
So automatically they burn it off so that way it's not there. There may be a little bit, but as you know, just because something's there doesn't mean that it's toxic, okay?
What about lead?
Well, yeah, and you're exactly right. But obviously it's not in a large enough quantity for them to conclusively say that the amount that you experience, if you had a hot pan...
I would like to have faith that if there was something as toxic as lead, they wouldn't be using it to make cookware.
No. Well, they once put it in paint and everything like that, but that was obviously...
We didn't know.
Yeah,
they know about the toxicity of this stuff,
Yeah. So the Cancer Council, it states that Teflon itself does not cause cancer. Some lab studies have shown that PFOA, which is obviously the chemical that's the PFOA, which is apparently burnt off during the making. Okay, it does increase the risk of some tumours in lab animals. However, this is still not conclusive.
Okay,
so it's inconclusive.
Limited research.
And they say there's limited research on this at the moment. However, the way it looks, it's inconclusive and it doesn't appear to do anything. So the Teflon and cancer risk is also, or primarily in relation to the fumes released from the Teflon. So what people are concerned about, well, okay, fair enough, all right, there's nothing that's in my food, but if you heat that pan up, things get hot, they start to produce odours and things like that. It's like when you have a pan, you can smell it burning. So one of the concerns was that. Now, according to the Australian Government Industrial Chemicals Notification and Assessment Scheme, for Teflon to release these compounds, okay, so what would they consider toxic compounds? One, it would have to obviously be in there, but secondly, it would have to be heated to, get this, 340 to 650 degrees Celsius.
Okay, yeah, that's a bit hotter than my oven gets to. Yeah,
so technically all that do is just incarcerate your food. Incinerate your food. Incarcerate. You're going to jail.
It's chicken in a prison.
Yeah. So it literally just set fire to your food, and so
if you're heating your food up to that sort of degree, you're just eating ash, and that is a carcinogen. So maybe that's where it comes from.
Maybe, yeah. But so that was kind of. I hope I addressed the main concerns for you there, Ben. So yeah, don't worry for now. This is probably what they said about lead as well. But once again, it's in small quantities if you are exposed to it, and it's not really conclusive that it does cause cancer. Obviously, you'll go to some websites where they'll talk about how this causes cancer, but then you need to look at the actual amount that you're ingesting as well.
But so far, these are the Cancer Council of Australia, and the other one was
the other one was the Australian Government Industrial Chemicals Notification and Assessment Scheme, or the AGICNAS.
Okay, so these are pretty reliable sources. That's probably where you should go for cancer information. Well done to you, sir.
No worries, mate.
Very reliable.
Yeah, I didn't go to mummyblog.com. It's all right. Okay, next question. What do we got here? We've got David Burgess. Just before daybreak, it feels colder. Is it something to do with the ionosphere?
Well, I know the answer to this.
What is it?
No. Next question.
Next question. All right, what's you got for us, Bert?
Okay, next question. How gas permeable is the ice that is being used as exemplars for ancient atmospheres?
Very good question.
That is a good question.
And you know what? I like questions like that because it's not like that's someone going, oh, that's
how
obviously
reliable
how reliable is the information I'm getting regarding climate change? And just like we hold papers and researchers and ideas to the sword when it comes time to assess our understanding, it's great to see people like Stuart actually asking questions like that. So, well, how reliable is the evidence that they're producing?
It is. So just to catch everyone up, basically a lot of our predictions with climate change, especially the ones that span over hundreds of thousands of years, come from ice core data. So we have certain levels of CO2 trapped in ice layers deep inside glaciers and the snow pack in northern and southern hemisphere. We extract these ice cores, we look at the amount of gas in them, different types of gas, so that's CO2 as well as oxygen gas, and from that we can get a pretty good reading, or we obtain a reading of carbon dioxide concentrations as well as the temperature of the Earth, however, 400, 500,000 years ago. Now, Stuart, the core of Stuart's question is, can these gases that are trapped in these layers move around? So if they move around, that would imply that maybe our reading isn't
they're not
accurate,
valid. Yeah,
maybe it is.
Yeah, I'd question the accuracy.
Yeah. So the first thing, I reckon this is a great question because I never thought about this. I reckon it's an excellent question.
I never did as well.
Yeah, so first thing I did is I had a look at gas permeability and how we determine it. Okay, so there's gas permeability is determined by a number of factors. This first one is a thing called diffusion flow, and this is where gas molecules are incorporated into a particular material before leaching out. So there's gas outside the material, they sort of get pushed in by a concentration gradient, they become part of the material, and then they slowly work their way through before they get out the other side, if you will. Okay, there's another one called laminar flow, where gas basically moves freely through pores in the material. So there's holes throughout it. The gas can go in and out of these holes and come out the other side, and there has to be a pressure gradient to drive that gas. And the last type of gas permeability is called molecular effusion, and this is a bit like laminar flow, but the pores are tiny. Okay, so there has to be a large amount of pressure to push the gas and drive movement between it. So laminar flow, there's big gaps, gas is a lot easier to move around. This molecular effusion, tiny little pores, so the gas has to be pushed into them. Okay, so all three of these permeability factors are present in ice. Now, the ice used for measuring specific ancient atmospheres has a variety of densities depending on how deep it is, how old it is, how well packed the snow is. The gases which make them permeable also are quite variable. So the diffusion flow, the laminar flow, and the molecular diffusion are different between all of these different layers. So it actually changes between the different ices. We haven't had one particular study on the specific ice cores we've extracted from, say, Antarctica or the Vostok, which is the famous one, ice core data. But when you start looking into it, we look at the types of atoms that are in the ice as well. So we have oxygen isotopes, different kinds, and that tells us the temperature. We also have different types of carbon in the carbon dioxide, and that gives us an idea of where the carbons come from. We also look at different kind of ice cores. So it's not like scientists just take out one ice core and go, yep, this is our reading for this whole area. They'll take a whole bunch of ice cores. So even though there is definitely some gas permeability through the ice, how they reduce or increase the reliability is they increase the number of ice core samples.
Okay, I was about to say validity or reliability, but yes, okay, they increase the number of ice core samples.
So if there are differences between them, they can go, okay, why are these differences there? And it might have something to do with the gas permeability. They also increase the number of locations they take samples from, so the north and the south as well. And generally what they find is there is a high level of agreement between all these different sites, all these different ice cores extracted from the same sites. And even though there is variable permeability between all these layers and all these different ice, a high amount of agreement between all these things means that there is a high amount of reliability for the readings we have. So scientists have taken into account
what a great question.
It is a good question.
That's an awesome question, yeah.
So scientists have taken into account the permeability.
A great answer.
Thanks, mate. Yeah.
That's awesome.
So we don't know the permeability because it's so variable. But we do try and account for that by increasing our reliability through repetition.
Wow. Well done, my friend.
Thank you,
Well
Wade.
done. And great use of terminology, validity, precision, and reliability. All mean different things.
Science.
Yeah, you science the shit out of those three terms.
Science the shit out of that.
Okay, now...
I really enjoyed that one. Thank you, Stuart.
Yeah, what a great question. Okay, so now I think we're up to... It looks like we're up to our favourite. Oh, wait, no.
We have a couple more.
Okay.
Oh, here we go. Sarah Reel Clark's child. So we had Sarah Reel Clark come on and she said this is her kid's question. Wade, this is right up your alley. Question is, why is blue?
Why is blue? Okay, so there's two factors to this. There's actually the photon, which is released from the sun, and obviously, or wherever it comes from, and the frequency of that photon which is released. And so you have to look at this wave particle duality, which is, I know it's really confusing, but that's what a photon is. It has properties of waves and a particle, kind of like an electron's a particle, but like a sound wave, or you know what I mean? Like it has a property of what you'd see like a wave, and it interacts like a wave. So when it has a higher frequency, so it has a shorter wavelength, that's where the blue end of the spectrum is. Okay, so when things,
the visual spectrum.
Yeah, the visual spectrum,
and then we get the violet as well. So
exactly, and then you get the violet.
Yeah, right.
And so and then obviously you get the ultraviolet, which is even higher frequency, and then you go all the way down to red, and then infrared, and to a point where you can't see. Infrared is, what's really interesting is, and a lot of people find this interesting who don't really have a science background, is explaining to them that heat is just a way your body detects a wavelength that is longer than red.
Yeah,
and
that is true. So when you walk out of the sun and you feel
you're like,
hot.
oh, geez, that's hot. It's like, well, all that is, that's your body interpreting a color that you can't see.
Yeah.
Which is really, really
That
cool.
is cool.
And then the weird part is it's a longer wavelength. You'd think it had heaps of energy, but it's just the amount it's releasing.
It's actually less.
Yeah, so firstly you get the blue color, okay? Or the blue wavelength, I should say. Let's forget color for a moment because we'll get to the eye. So what happens is as that blue kind of color comes through, or that frequency, it's the way in which our brain interprets it that it actually determines it to be blue. So as you know, we've got different photoreceptors in our eye. You'd know this being a biologist.
Yep, 3 different
okay,
colors.
3 different, red, green and blue. How each of those are triggered, okay, from the incoming, say, photon, which is the little frequency, okay, the blue photons, and they will stimulate the photoreceptors on the eye, which are located in parts of the retina, on the back of the retina, which we refer to as photoreceptors, which are actually called cones. The easiest way of remembering the difference between cones and rods is that hippies punch a lot of cones so they see colours. That's how I remember it.
I did not remember it that way.
Yeah, I do. And so obviously you got rods, which obviously help with different, like the shades and then movement and all that type of stuff. But
Maybe rods are better for not colours because you're more likely to get ramrodded at night.
Oh, that's a terrible definition. That was shit. So it comes in, and then all of a sudden you have, all of a sudden it stimulates. So you got the red, green, and blue. Now, when they're triggered or fired off, they will send a message to the brain. Now, animals, say dogs and things like that, well, they see a different set of colours to what we see, and it's only because different parts or those photons are actually interpreted by their brain to be a different colour.
Okay, so their photoreceptors are the same, but they just get interpreted by the brain differently. So there's 3 parts really to this answer.
Well, yeah, okay, I guess there are.
I hope your kid's pretty old there, Sarah, because this is quite a complex answer.
Well, it is, but that's the beauty of it, is that, you know, what is blue to us isn't blue to a dog.
Wow.
What is blue to us isn't blue to, say, even people who have had head injuries or strokes, things like that, they lose their ability to interpret colour. In some cases, everything just becomes a shade.
It is weird when you think about that. What I see as red, you might see differently.
Well, a lot of people worry about that, but there's actually tests you can do online. So colour blindness tests you can actually do online, which actually determine if you are indeed colourblind or if you are in seeing something as different to everyone else.
Yeah,
so
but if you would say your red is what I would see as green, for example, if we swapped eyeballs or something like that.
Yeah,
there is no real way to prove that. If you were brought up saying that colour is red, and I was brought up saying that colour is red, but how our brain interprets it is different.
Yeah, but you'd be able to identify it.
We're both looking at a red flag.
Yeah, I know.
Right now
Red.
what colour do you see? Yeah. Well, red, you idiot. Yeah.
So, in short, if you want to explain it to a kid, you would generally say that, okay, so there's certain little waves that are produced by the sun. So sunlight, there's little waves of sunlight. When they all mix together, they make this beautiful, clear, what they call white light. And there's little parts of that when they go to your eye, your brain says, oh, that's blue, like the sky, for instance. And it goes, oh, that's a blue sky. Now, what you see is blue, and another animal might go, oh no, the sky is this colour, or grey, or whatever. So it really depends.
Like an Englishman.
Yeah.
The sky is grey.
The sky is grey. So that's probably the best way of dealing with it. It's got to do with the way our eyes are the human eyes. But there are different animals that see colours the same, like lizards and things like that. They are actually able to
birds are pretty close to ours as well, I think.
Yes, birds as well. So yeah, that is why is blue. So
why
blue
is
is blue? It's very relative to. It's relative to what animal you are, what species you are, and how your brain interprets that wavelength.
Good on you, Sarah, for raising a curious kid and following through, not just going, what a stupid question, go to your room.
Yeah, I know, exactly.
All right, next question comes from Eric Garn. Oh, this looks up your alley as well, Wade. Is thorium really a good power source? I feel like we've covered this.
We have covered this in a previous episode on nuclear power. So if you go back and you have a look, an episode we did, what season was it? It might have been
fusion and fission bombs or something.
Yeah, from fusion to fission bombs. And so have a look at that. We'll go back through our catalogue and you'll actually see we actually address a lot because it's not a clear-cut question as is thorium good, is it bad?
It's grey?
You know what I'm saying? It is not black and white. Well, it depends if you can interpret that colour the same as I can. Okay, and finally, yes, it is our last question. Where did you get the inspiration to create Sci-gasm? Also, what is the monthly quota for dick jokes? What is it?
What, the quota or the inspiration?
Well, I can tell you right now, the quota, we have blown that out for the next 4 years in this. The amount of dick jokes. Okay, so where do we get the inspiration to create Sci-gasm? Pubs. Yeah, there's definitely a lot of
pub
conversation.
definitely played a significant role in the creation of Sci-gasm.
Yeah, and as well, we get along like a house on fire. We pretty much do most things together. And we just...
Gay marriage just came in too late, really.
Yeah, I know. It was just too late for us. Our ship had already sailed on that one. But I guess the inspiration came up because... and this is what we base our whole podcast on. And we've done a number of interviews with other shows and things like that. And the reason we... have started this is we wanted to get the kid who fell asleep in science class back into science, because let's be honest, they're now old enough to vote. And they've got to make decisions that not only just political ones, environmental ones, but they're also making decisions for other people as well, and that being their kids and family, and they may look after their parents and need certain types of treatment and a whole range of different things. And I
think we all see there's a lot of problems that the world still has. The world's come a long way then from the past, but a lot of those problems have been solved by scientific endeavours.
Absolutely,
and there's a lot of problems we still have, and I think, at least my perspective, and I don't want to be so bold to speak for here, Wade, but I will anyway.
No, go for it.
Is science still has the potential to solve so many of our world problems, and there are so many people that are frankly science deniers, and Wade and I have a problem with that, and we want to change that.
And also make it make science cool again. And I can see that coming through now. People are actually giving a shit about science, and I'm really happy to kind of see intelligence is now becoming a desired thing.
Yeah, it's fun. This is fun. It's fun to learn shit and know stuff, and it's mind blowing.
I have learnt way
dogs
more.
See different colours and shit. That's cool.
I know. I have learnt way more in my studies for this show and researching topics and developing an opinion on things,
speaking to experts,
than I have in all the undergrad and postgrad and research I've done.
Prescriptive learning.
All that type of stuff. Just getting involved in chat groups and the skeptical community and stuff like that has been an absolutely life-changing thing to a point.
Some of the uni courses are so boring, and we want to make it fun again. So we crack a dick joke here and there and throw in a bit of science with it. And we hope you enjoy it.
We really do hope you guys enjoy it, because we love doing it. And I think, in all honesty, we are literally putting a microphone in front of what we used to speak about. And I remember we used to drive, it was funny enough, when driving our way to the pub after work, we'd always talk about, how great science is and how lucky we were to have, an education in science and to be able to analyse and critically think about anything. And we're like, we should start recording this. And our fucking first few episodes, we haven't actually released the first one.
If you'd like to hear the first one, you should become a Patreon.
You should become a patron, because we've got a surprise for our patrons. We're going to put up that first episode. It is fucking dreadful.
We like to think we've refined it a bit, but I think we've just become more talkative and put a few more dick jokes in, really.
We've just become more opinionated, more swearing, and some reason it just got us more comfortable. All right, thanks, guys.